Hello scholars, welcome. Mr. Hinkle here. In this lecture, I want to talk about an issue that we have all heard about. It is a global phenomenon. It's gone by multiple different names: global warming, climate change, anthropogenic climate change. And in this lecture, I want to explain the science of how climates change and what we are experiencing in our current climate change event. So let's get into it. We will define Earth's climate system, talk about the greenhouse effect and greenhouse gases. These are crucial to regulating and maintaining a stable global climate. Discuss historical records of recent climate change, and then identify the human impacts to our climate system. And the goal is for you to have a foundational and informed understanding of what is climate change. Let's get into it. So, Earth is a system, and the Earth system is composed of multiple spheres. Within the Earth system, there is all of the life on Earth, the biosphere. There is all of the rock on Earth, the geosphere, also known as the lithosphere. All of the water on Earth, the hydrosphere, where this sometimes pulls out the ice because ice plays such a key factor in our global Earth system. And then we have all of the air, the atmosphere. Now, these spheres do not work in isolation. They work in harmony. Our Earth system is based on the complex interactions between the biosphere, geosphere, hydrosphere, and atmosphere. Well, we can also think about the climate system, which is going to be the exchange of energy and moisture between the spheres. So, Earth is a complex place where we have many different complex interactions going on between the life, the rocks, the air, the water, the ice, but also our Earth's climate, which is the long-term averages of the weather conditions that are available at a given point in time, is highly influenced by these interactions of Earth's spheres. So climate change is interconnected between all of these: life, rock, water, air, and the oceans play a major component in Earth's climate system. Oceans covering 71% of Earth's surface, land covering 29% of Earth's surface. And so when we think about climate change, what we are experiencing is changes in Earth's climate system. Great. Let's keep going. So I live in Fresno, California, where in the summertime it gets hot. If you live in the Central Valley, you know exactly what I'm talking about. In fact, sunshades have been known to melt in extreme heat conditions. And this example of people baking cookies in their car because it's so hot in the car. What the heck? Well, it doesn't get as hot as an oven, but inside of your car, it might. And this is because of the greenhouse effect. Now, this is a metaphor for what is happening in our atmosphere. And it goes a little something like this. Here is your car. A couple wheels. And it's got windows. And it's got the chairs, steering wheel, so on and so forth. Excuse my rudimentary drawings. Up in the sky is the sun. Well, the sun is heating the surface of the Earth. Let's say it's 110 degrees outside, and whew, oh boy, that's a hot day. let me tell you what. But 110 degrees is not enough to bake cookies, and it's not enough to melt sunshades. But inside of the car, we're baking cookies and melting sunshades. So what's going on? Well, it happens like this. The heat from the sun makes its way through the windows, and it heats up the interior. It heats up the seats, it heats up the dash, it heats up the steering wheel, it heats up the floorboards, it heats up everything. That heat then tries to escape, but it's trapped inside of the windows because of the form of heat transfer that is occurring. So, energy from the sun heats up the inside of the car, but then that heat is trapped because of the windows. That heat cannot escape. This is similar to what's happening in our atmosphere with the greenhouse effect. So what process is occurring inside of your car to bake cookies? The greenhouse effect. Let's take it to an actual greenhouse. So a greenhouse is a structure that is used to grow food when there isn't enough heat. And the process is very similar. Let's bring our sun to over here. The sun, now let's say the ambient air temperature outside is 45 degrees, but we want to grow tomatoes. And so we need a warmer temperature in order to grow these plants. So energy from the sun heats up inside of the greenhouse, but then inside of the greenhouse, the plants and the earth are releasing heat, but that heat cannot escape. So 45 degrees ambient air temperature on Earth heats it up to 70 degrees inside. 110 degrees air temperature heats it up to 140 degrees inside. The heat is trapped. And so this is crucial for maintaining a regulated climate inside of the greenhouse, inside of the car. Now, our Earth is very similar to the greenhouse or to the car, where I'm going to, let's go down here. Here's Earth. Earth's atmosphere. Light from the sun comes down, heats up the surface of the Earth, but then Earth emits that heat, and the heat is trapped, not by glass or plastic, but by particles in the atmosphere known as greenhouse gases. These greenhouse gases that are located, which are carbon dioxide, methane, nitrous oxide, water vapor, ozone, and hydrofluorocarbons, are absolutely crucial for life to exist on Earth. If our atmosphere did not have greenhouse gases and the greenhouse effect did not exist, then daytime temperatures would be really, really hot and nighttime temperatures would be really, really cold, and we would not have the stability of climate through time that has allowed life to evolve, that supports life on Earth today. So, the sun is the primary source of energy for all life on Earth. And the heat from the sun, solar radiation, transfers down to Earth in a wavelength because it's light in the electromagnetic spectrum. Shortwave radiation from the sun arrives to Earth. It heats up the land and the sea. Then that heat is re-emitted in the form of long-wave or infrared radiation, which travels back up. It interacts with greenhouse gases in the atmosphere and then is re-emitted back down to Earth. Now, this phenomenon of Earth's heat being trapped inside of our atmosphere. This is the greenhouse effect. The greenhouse effect is a natural process, and we would not be here without it. So we can acknowledge, that this is a natural process, a natural phenomenon. It occurs in our Earth's atmosphere. It plays a crucial role in regulating the planet's temperature, and it makes the planet habitable as we know it. Shortwave radiation from the sun reaches, heats up the surface of Earth, land and sea, emits long-wave or infrared radiation, which is absorbed by greenhouse gases and is re-radiated back into Earth. Similar to the sun heating up inside of your car, and then the inside of your car being the heat there being trapped in by the windows. Similar to the greenhouse, the sun heating the inside of the greenhouse and that heat being trapped inside of the structure, thus giving us the greenhouse effect, a totally natural process. So let's talk about another natural process, and this natural process is known as the carbon cycle. So carbon is an element necessary for life, makes organic compounds, and it moves through various reservoirs on Earth. So let's say, here's our Earth. There's carbon in the rocks. Carbon is emitted through volcanoes. Carbon is stored in life. So you can see carbon making its way through. Oh, and then it's also out here in the atmosphere in the form of CH4 and CO2. So you can see carbon moving through all of Earth's spheres. The geosphere, the biosphere, the atmosphere. Carbon is transported in the wash load in rivers all the way back into the oceans, where it deposits as marine sediments and it forms biochemical sedimentary rocks. It's a bit of a geology lecture there. Focusing on climate change, let's stay here for now. The movement of carbon through various reservoirs on Earth is a natural cycle. There is carbon in the atmosphere. There's carbon in life right now. I am made of carbon. In fact, every breath I take in, oxygen. Every breath I take out, carbon dioxide. So I am a carbon emitter. We all are carbon emitters. The biggest sink for capturing carbon is the ocean, which then deposits that carbon into the bottom of the ocean, creating limestone, where these rocks on Earth's surface, sedimentary rocks, will remain for millions of years. It's a very long time that these rocks are going to be down there. Millions of years. Okay, great. So again, another natural process. We built the greenhouse effect, the carbon cycle. Let's put these up here because they are huge ideas. The carbon cycle is what's known as a biogeochemical cycle. Bio, life, geo, earth, chemical, could be carbon or nitrogen or phosphorus or any of the other crucial elements that are necessary for life to survive. So let's go into the anthropogenic effects of this. Anthropogenic climate change that is happening on Earth today, is being impacted by human activities because of this. So, right now, our Earth is dependent on fossil fuels. We use coal, oil, natural gas to power our societies. These are called fossil fuels because the energy was created from once living organisms, fossils, that exist in the rock record. So we have these, let's go into an ocean basin. Here's land, here's the ocean, and then here's where the fossil fuels live. I've discussed this in another lecture, the formation of fossil fuels, but right now, for our intents and purposes, Here is a drill well. Boop, boop. So carbon in these fossil fuels that exists in the stratigraphic record is pumped out of the earth and then refined and used for our society. And what this does, the extraction, refinement, and combustion of fossil fuels, is it takes carbon that was in the geosphere and it puts it into the atmosphere. So now we're increasing the amount of greenhouse gases. More greenhouse gases in the atmosphere would be like adding more layers of glass onto your car. And if you've ever gotten double pane windows, you know that the more windows that you stack up, the more insulating that you get, the hotter it's going to get inside. And so more greenhouse gases equals more insulation. The greenhouse effect continues, and ultimately what happens is the temperature of Earth increases. Earth surface temperatures increase. That's not the only thing, but that is one impact. So more greenhouse gases trap more heat, causing Earth's average temperature to rise, leading to environmental and climatic impacts, sea level rise, extreme weather events, ecosystem disruption. This is the short list, but the long list of effects due to anthropogenic climate change is quite extensive. Let me offer a little bit of a summary. The greenhouse effect, natural process that regulates Earth's temperature. The carbon cycle, a natural process which is the movement of carbon through Earth's various reservoirs. Fossil fuels pull carbon from the geosphere where it would be for millions of years and combust it into the atmosphere. Now, the ocean is the carbon sink, so it's pulling a lot of, it's offsetting how much we're actually burning, but that is another discussion. So let's talk about what do we know. 1958, on top of Mauna Loa in Hawaii, atmospheric carbon dioxide measurements began and have continued ever since. Let me see, I've got a little pointer here. David Keeling started these measurements, and this is called the Keeling curve. And what you see is atmospheric concentration has steadily increased, and there's a seasonal variability that you see because spring blooms will pull carbon out, and then when the plants aren't growing or blooming anymore, there's more carbon in the atmosphere. So direct measurements on historical record is showing an increase in the amount of greenhouse gases. We've measured this. It's recorded. It's there. Temperature. As soon as humans learned the technology to record temperature in the 1880s, global temperatures have been recorded. And so what we've seen, what we have directly measured, is a trend that's increased from cooler to warmer. About 0.14 degrees Fahrenheit per decade, which has shown about 2 degrees Fahrenheit in total. So this overlaps with around the dawn of the Industrial Revolution. What we have recorded and what we see now, right, is that most recently, the 10 warmest years have happened since 2010. September 23 is the hottest September ever recorded. Temperatures are warmer. Now, the effects of climate change isn't that the whole world gets warmer. Some places get warmer, some places get cooler. Climate patterns are disrupted. You have extreme weather events that are occurring. Again, the list goes on and on and on. But if we're thinking about the science of climate change, this is what is important for us to think about. We have recorded CO2 in the atmosphere increasing, global temperatures increasing. Okay, so what do we compare this against? Well, science is so cool, and we can use climate science to assess paleoclimates, which means ancient climates, through gas bubbles that are trapped in ancient sea ice. Greenland, Antarctica, been covered in ice in a very long time. And drilling cores down into the ice, we can reconstruct the amount of atmospheric carbon dioxide over the last 800,000 years. And what we see is a natural variability. Carbon increases, carbon decreases, carbon increases, decreases, so on and so forth. So complex systems are variable. They usually happen in patterns and trends. And we see this. We see patterns and trends in global CO2 atmospheric concentration. Now we take this from the 800,000 years to today, and we see that over the last 150 years, where we're at now, over 400 parts per million, carbon dioxide concentrations in the atmosphere are higher than they have ever been in the last 800,000 years. This is why climate scientists and the scientific community are alarmed due to the current practices of burning fossil fuels that is combusting and putting more carbon dioxide in the atmosphere than we have ever recorded through natural geologic processes. It's a big deal. So, recorded increased CO2, recorded increased temperature, but the question is, are CO2 and temperature correlated? And the data indicates that there's a natural variability of CO2, there's a natural variability of temperature. And temperature and CO2 from paleoclimatic evidence shows increased CO2, increased temp. Decreased CO2, decreased temp. So yes, what the evidence shows is that during periods of increased atmospheric CO2 levels, we have increased global temperatures, which has a variety of impacts to ecosystems on Earth. But just talking about the science right now, if we've seen this in the past and we know that this is happening now, then we can predict that the current rates of global warming, the average temperature of Earth's surface, it's not a certain point at one time. Certain places can get colder. But the average temperature of Earth's surface is increasing, and that is going to continue to increase. So let's put this all together. Everything's summary. The greenhouse effect is a natural process that supports climate stability, and the carbon cycle is a natural biogeochemical cycle that highlights the movement of Earth's carbon. Well, burning fossil fuels pulls carbon out of rocks that would be there for millions of years and combusts it into the atmosphere, increasing atmospheric concentrations of carbon dioxide, which will lead to increased Earth surface temperatures that we've already recorded as happening since the dawn of the Industrial Revolution. So humans, the conclusion, humans are altering the environment. We're altering the climate system through the burning of fossil fuels by increasing atmospheric greenhouse gas concentrations. This is science. This is what we know about how our Earth system works, and this is what we have recorded in recent history that we know to be occurring right now. This is anthropogenic climate change. So it sounds bad, but I want to leave us on a positive note. There are a million reasons to stay positive. human beings are creative and we are ingenuitive and we can solve complex environmental problems. And I believe that you may be the person to help bring us into the future. So in order to do that, though, we've got to keep a positive attitude. This leads to more effective action and contributes to a better future for our planet. I am hopeful. I believe that humans are going to overcome the climate crisis, combat recent climate change, work together in order to bring our climate system back into balance where it was before we began burning fossil fuels. Science alone will not save the earth. The science of it is for understanding, but the actions that we take will need to occur through personal decisions, through environmental policy, and it's going to happen through the human sphere. You and I working together, making decisions, informing policy, voting for an environmental agenda that will help to combat this climate crisis that we are currently experiencing. So we can do this through these 9 different avenues: learning and education, watching this video, understanding, taking a climate change course at your local university, educating yourself to the issue so that you have a fundamental understanding, and that's what I'm trying to do in this video, provide a fundamental understanding of climate change. Motivation. We need to be motivated to have conversations, to be compassionate, to listen, to innovate and create technology. Our engineers and our people on the ground creating new technologies, because in order to divest from fossil fuels, we need a very diversified portfolio of alternative sources of energy. There's no magic elixir that is going to save us, but it will take hard work and good ideas. We need to work together as a community, a global community where we collaborate. We need to be resilient to the naysayers, to science denial. We need to be resilient to overcome these major challenges that are standing in our way. We need to take personal responsibility and live sustainably. We need to provide hope for future generations, advocate for policy, and come together in global solidarity, because climate change truly is a global phenomenon that will take every person on this earth working together in order to overcome what is the biggest environmental issue of our generation. Thank you so much. This is the science of climate change. I hope that this provided a background foundational knowledge for you to understand what is happening currently in our climate system.